Okay, in section 2.8, we are going to discuss a very important skill, the skill of solving inequalities. This is going to be highly important once you get to calculus to be able to know how to do this. And so in example 1, I just want to determine the x values that cause this function f of x to be 0, positive, and negative. And this is all done through the use of what is called a sign chart. And so I'm going to draw a number line here in order to set up this sign chart, and what goes on my number line are the zeros of this function. And so if I set this equal to 0 and solve, from the first factor I get that x minus 2 must equal to 0, which means that x must equal to 2, and I'm going to put 2 down here for the time being. For the middle parentheses, we're going to get x squared plus 3 is equal to 0. Well, if I try to solve that, I'm going to get x squared is equal to negative 3, and so x is equal to something imaginary, plus or minus the square root of 3i, and I can't put imaginary numbers on the real number line. So I'm just going to disregard that and not get any critical numbers from that particular parentheses. And then finally, for the last one, I just take x plus 5 and set it equal to 0, and that's going to give me x is equal to negative 5. Now, I have 3 different sections of my number line to test. I have this one here, this one in the middle between negative 5 and 2, and then from 2 to infinity. And so I'm just going to start taking values on this number line and substituting them into the function to figure out if I get something that's positive or negative. So if I start by, say, let's plug in negative 6, that's a number that's between negative infinity and negative 5, what am I going to get as a result? Well, if I plug into this first parentheses, negative 6 minus 2 is going to be negative, and so I'm going to start by putting a minus sign right here. Now, this middle parentheses, let's chat for a second about x squared plus 3. Can we all agree that no matter what number I put in there for x, it's always going to be either positive or 0? No matter what I put in, I'm always going to get either a positive or 0 value here for x squared. Then when I add 3 to that number, that's going to make it even more positive. And so I am always going to get a positive result for that middle parentheses. By the way, I'm also going to get a positive result for this parentheses. Why? Because of the square. Anything squared is always going to be either positive or 0, and since negative 5 is what makes it 0, we know we're not going to test that number because it's actually on the number line, and so therefore I know that that parentheses is also going to be positive no matter what x is, as long as I don't plug in one of my zeros. So a negative times 2 positives is going to give me a negative, and now when I go to the future sections, I know I don't even really have to plug in to those last 2 parentheses. Really the only one I have to plug into is the first one. So in the middle, I could plug in 0. That would definitely be the easiest thing to plug in. 0 minus 2 is negative, and then the other 2 parentheses are positive no matter what, and so this is going to be negative. And then finally, from 2 to infinity, I could plug in 3, and so now 3 minus 2 is going to give me positive. The other 2 are going to be positive no matter what, and so there's going to be my positive interval. Okay, so for letter A, what values of x are going to make this function 0? Well, that's going to be the set of 2 numbers, negative 5 and 2. So I don't write that as an interval, I just write it as the set of 2 numbers, negative 5 and 2. For letter B, we want the values that make it positive, not 0, just positive, and so just positive would be the interval from 2 to infinity, and I'm not including 2 because 2 makes it 0. It does not make the function positive, so that's why I'm not including 2. And then finally, negative is going to be from negative infinity. I'm going to stop at negative 5 and not include it, because if I were to include it, negative 5 is a number that makes the function equal to 0, not negative, and so you got to be careful there not to include negative 5, and then I'm going to go from not including 5 until not including 2. And I don't include 2 for the same reason, because all we're looking for here is negative, not 0. So, for example, that would be an inequality sign that looked like that, less than 0. Positive would be greater than 0. 0 would be equal to 0. And we're going to talk about greater than or equal to, less than or equal to in future examples, but for this particular example, the way it's worded, that's how we would answer the question.